Morning to one and all. Myself, Dr. M. RENUBABU, working as an associate professor in Department of ECE in Tegal Krishnareddy Engineering College, Hyderabad. Today, you are going to learn about the introduction to embedded system design. So these are the contents: introduction to embedded system, definition of the embedded system, then differences between embedded systems versus general computer system, history of embedded system. Then we'll learn about the classification of embedded system, major application areas, purpose of embedded system. Finally, we are going to learn about the characteristics and quality attributes of the embedded system. So, embedded system is one of the important subject you need to know, because in our daily lives, we are seeing so many electronic gadgets and so many electronic equipments. So, we in which equipment and in which devices these embedded systems are using, that we have to be know. Examples like in TV, microwave oven, washing machine, refrigerators, in all devices and equipments are using the embedded system. So we need to know what exactly the embedded system was. So let us see, before define the embedded system, as we need to know the system. What is system? System is a way of working or organizing one or many objects according to a plan or set of rules. This is called as system. So let us take the example watch. Watch is a mechanical system. Okay. It displays the real time. Its components are battery, needles, chassis, and straps. This is not a embedded system. These watch components are follow the some set of rules, and it shows the real time. So all the components are depends upon the each other. So let us define the embedded system. So what is an embedded system? An embedded system is an electronic electromechanical system designed to perform a specific function, and it is a combination of both hardware and software. The program instructions written for embedded systems are referred as firmware and are sorted in read-only memory or flash memory. So let us take, these are the examples of embedded system. This embedded system can be used in smartphone, cameras, washing machine, electronic book tablets, television, industry and air navigation systems, broadband networking. So everywhere we are using the embedded systems. So let's see the differentiation between embedded system versus general computing system. So let us take first one is, in a general computing system, it is a combination of generic hardware and a general purpose operating system for executing a variety of applications. Whereas in embedded system, it is a combination of a special purpose hardware and embedded operating system for executing a set of specific application. And coming to the operating system, it contains a general purpose operating system, and in embedded system, it may or may not contain operating system. So whereas here in general computing system, the applications are alterable by the user, whereas here in embedded system, the firmware of the embedded system is pre-programmed and it is not alterable by the end user. So the main key factor, the performance is the main key factor in the general computing system, whereas here the application specific requirements are the main key factor in the embedded system. The power consumption is more in general computing system, whereas the power consumption is very less in a embedded system. Here the response time is not critical. Here it is highly specialized purpose, and for a certain category of embedded system like mission critical system, the response time requirement is highly critical. Okay. Next, we'll see the history of embedded system. The first recognized embedded system is the Apollo Guidance. It was developed by MIT Lab Industry. It has two modules. The first module is command module, whereas the second module is lunar exertion. And the Apollo Guidance computer system, its RAM size is 256, 1K and 2K words. Its a ROM size is 4K, 10K and 36 words. Its a clock frequency is 1.024 megahertz. And here in the AGC system, we can use 5000 and three input RTL NOR gates are used. Here the user interface is display keyboard. And the first mass produced embedded system is Auto Ionics D17 guidance computer for Minuteman I missiles. Next, let's go for the classification of embedded system. The classification of embedded system is based upon the four following criteria. The first criteria, it can be classified based on the generation. It can be classified on based on complexity and performance. And it can be classified based on the deterministic behavior and triggering. Okay, we'll see one by one. First, the first classification is based on the generation. The first generation, we'll see the based on generation. In the first generation, the early embedded system was built with the around 8-bit microprocessor like 8085 and Z80 and 4-bit microcontroller. So examples are stepper motor, and we can use the control units like automatic control units in the stepper motor. And we can see the digital telephone keypad also. And coming to second generation, these embedded system built around 16-bit microprocessor and 8-bit microcontroller. So the examples of the second generation is like SCADA and data acquisition systems. Whereas in the third generation, these embedded system built around the 32-bit microprocessor and 16-bit microcontroller. Here we are using the application specific instruction set of processors like digital signal processor and application specific integrated circuits. These instructions set is very complex and very powerful. And let's see the fourth generation. This fourth generation embedded system built around a 64-bit microprocessor and 32-bit microcontroller. Here, this system built around a system on chip, reconfigurable processors, and multi-core processors. It brings high performance and it has tight integration and miniaturization into the embedded system device market. Okay, next we'll see the embedded system based upon the complexity and performance. So the first one is, it can be classified into small scale embedded system, medium scale embedded system, and third one is the large scale embedded system. Whereas in terms of the small scale embedded system, these embedded system built around low performance and low cost 8 or 16-bit microprocessor and microcontrollers. It is suitable for simple and where the performance is not time critical. It may or may not contain the operating system. Whereas coming to medium scale embedded system, these embedded system built around medium performance, low cost, 16 or 32-bit microprocessor as well as microcontrollers, or we can use DSPs also. These are slightly complex in hardware and software. It may contain general purpose operating system and real-time operating system also. Coming to third one is large scale embedded system. These embedded system built around highly performance with 32 or 16-bit RISC processor and controllers. And we are using the multi-core processors and PLDs. It requires complex hardware and software. These systems may contain multiple processors or controllers and core units or hardware and accelerators for uploading the processing requirements from the main processor. It contains RTOs for scheduling, prioritizing, and management. And coming to the Third classification is it is based upon the deterministic behavior. So it can be classified into two types. One is the soft real-time system, and second one is the hard real-time system. So here in the soft real-time system, missing a deadline may not be critical and cannot be tolerated to a certain degree. And hard real-time system, missing a program task execution time deadline can have catastrophic consequences. Okay. Whereas coming to the next category, classification based upon the triggering. So it can be classified into two types. First one is a event triggered, and second one is a time triggered. So in the event triggered, the activities within the system are dynamic and depends upon the occurrence of different events. Whereas coming to the time triggered, activities within the system follow a statistically computed schedule and thus by nature are predictable. So next we'll see the applications of embedded system. Here, these embedded system can be used in so many applications, like it can be used in household appliances, consumer electronics, automotive industries, home automation and security system, telecom, computer peripherals, and it can be used in computer networking system, healthcare monitoring system, banking and retail, card reader, measurements and instrumentation, missiles and satellites. It can be used in robotics, motor control system, entertainment system, and also it can be used in signal and image processing. So let's see the household appliances. So what are the household appliances? Household appliances are like a television, DVD players, washing machine, refrigerators, microwave oven, etc. These are the household appliances. Whereas coming to the consumer electronics, these embedded systems are built in cameras and cam recorders. And coming to automotive industries, it can be used as an anti-lock brake system, engine control, ignition system, and automatic navigation system, etc. Then coming to home automation and security system, we have the air conditioner, sprinkler system, and closed circuit television cameras, fire alarms, all are under the home automation and security system. Coming to telecom application, so we have the cellular telephones, telephone switches, handset, handset multimedia, all these are applications under the telecom. So coming to computer peripherals, like we have a network routers, switches, hubs, and firewalls. All are the under computer peripherals application. Like you have the healthcare monitoring system. So like here we have different kinds of scanners like EEG, ECG machines, etc. All are these under healthcare monitoring system. Next, coming to the application of banking and retail. So here, the banking and retail applications are like automatic teller machines and currency counters and point of sales. These are banking and retail application. And coming to card reader, like barcode, smart card readers, handheld devices, all are under card readers. And these embedded system can be used in measurement and instrumentation applications, missiles and satellite communications, and this can be used in like robotics, motor control system, entertainment system. Finally, it can be used in signal and image processing applications. So these are the applications of embedded systems. Okay. Next, we'll see the purpose of embedded system. It can be classified into data collection, storage and representation, data communication, data processing, monitoring, control, and the final purpose of the embedded system is application specific user interfaces. Okay, let's see data collection, storage, and representation. So here, first of all, it performs acquisition of data from the external world and the collected data can be either analog or it may be a digital. So the data collection is usually done for storage, analysis, manipulation, and transmission. So here, the collected data may be stored directly in the system or may be transmitted to some other system, or it may be processed by the system, or it may be deleted instantly after giving a meaningful representation. So let us take the example of data collection, storage, and representation is camera. So it capturing the image, that is data collection. After capturing the image, it has to store. Then finally, it has to represent the image. So that is the camera is a example of data collection, storage, and representation. And coming to the next classification, data communication. So in this data communication, the embedded data communication systems are deployed in application ranging from complex satellite communication systems to simple home networking system. The embedded data communication systems are dedicated for data communication. So it can be used for specific data applications. So the data communication can happen through a wired interface like Ethernet. We are using RS-232 communication port, and also we can use USB port, IEEE 1394, etc. Or we can use wireless interface like Wi-Fi, GSM, GPRS, Bluetooth, and Zigbee also. Here, for data communication, we are using the network hubs, routers, switches, modems, etc. So the typical examples for a dedicated data transmission embedded system is like a Zigbee Wi-Fi module. So the diagram shows the Wi-Fi module. So this can be used for data communication purpose. Next, let us go for the signal processing. So these embedded system with signal processing functionalities are employed in applications demanding signal processing like speech coding, synthesis, audio video codec, transmission application, etc. These data processing can be used for hearing disabled persons to enhance the speech quality, and here the computational intensive system and employs digital signal process can be initiated. Okay, and the next purpose of the embedded system is monitoring. So these embedded system coming under this category are specifically designed for monitoring purpose. They are used for determining the state of the some variables using input sensors. They cannot impose control over variables. Here, for monitoring, electrocardiogram machine can be used for monitoring the heartbeat of a patient is a typical example for this monitoring application. The sensors used in ECG are different electrodes connected to the patient's body. And after connecting this ECG to the patient's body, it will be monitors the heartbeat of a patient. Okay, so the measuring instruments like digital CRO, digital multimeter, logic analyzer, etc. are used in control and instrumentation applications. And also these are used for monitoring purpose. Next, we have the controlling unit. So these embedded system with control functionalities are used for imposing control over some variables according to the change in input variables. So embedded system with control functionality contains both sensors as well as actuators. These sensor and actuators plays very important role to monitor the conditions. These sensors are connected to the input port for capturing the changes in environmental variable or measuring variable. Next, coming to the another classification is application specific user interface. These embedded systems which are designed for a specific applications, and it contains application specific user interface rather than the general standard like keyboard display units. So it's aimed at a specific target group of users. Like for the application specific user interface, we can use like example is mobile handsets. control units in industry applications or etc. are the examples for application specific user interfaces. Next, coming to the next topic is characteristics of embedded system. These embedded system can be characterized application and domain specific. The second one is reactive and real time. The third characteristic, it operates in harsh environment and it can be used as a distributed system. And the another characteristic is small size and weight. Next, power concerns. All these are the characteristics of embedded system. Then we'll see the first one is application and domain specific. So here in the application and domain specific, each embedded system has a certain functions to perform and they are developed in such a manner to do the intended functions only. They cannot be used for any other purpose. So example, the embedded control units of the microwave oven cannot be replaced by with the ACs. So AC is embedded control unit because the embedded control units of the microwave oven and ACs are specifically designed to perform certain specific tasks. And coming to the second characteristic is reactive and real time. So here in reactive and real time, these embedded systems are constant interaction with the real world through sensors and user-defined input devices which are connected to the input port of the system. If any changes in the real world are captured by the sensor or input devices in real time and the control algorithms running inside the unit reacts in a designed manner to bring the controlled output variables to the desired level. These embedded system produces changes and in input output responses to the changes in input. So they are referred as a reactive system. So the real-time system contained means the timing behavior of the system should be deterministic in the system. And that is the system should respond to request is known as amount of time. Okay, what are the examples of reactive and real-time system? That are the embedded system which are mission critical like air navigation system, flight control system, anti-lock brake system, etc. are the real-time system. And the third characteristics, it operates in harsh environment. The design of embedded system should take care of the operating conditions of the area where the system is going to implement. The example of the operate harsh environment is if the system needs to be deployed in a high temperature zone, then all the components are used in the system should be of high temperature grade. So also a proper shock absorption technique should be provided to system which are going to be commissioned in place subjects to high shock. And coming to the next characteristics is distributed characteristics. So what do you mean by distributed characteristic? It means that the embedded system may be a part of a larger system. Many members of such distributed system from a single large embedded control unit. The example, what are the example for this distributed system is like automatic vending machine. It contains card reader, a vending unit, etc. Each of them are independent embedded units, but they work together to perform the overall vending functions parameters. Next, another characteristics of embedded system is it's a small size and weight. So the embedded product size is an important factor in choosing the product. It is convenient to handle a compact device than a bulky product. Then the final characteristic is power concern. So the power management is another important factor that needs to be considered in designing embedded system. These embedded systems should be designed in such a way to minimize the heat dissipation by the system. Okay, these are the some of the characteristics of embedded system. Then we'll go for the quality attributes of embedded system. These quality attributes of the embedded system can be classified into operational quality attributes and non-operational quality attributes. So the operational quality attributes are again can be classified into response, throughput, reliability, maintainability, and this maintainability again can be classified into scheduled or periodic maintenance, maintenance to unexpected failures, and another operational quality attribute is security and safety. So we'll see the one by one of the operational quality attributes. The first operational quality attribute is response. So it is the measure of quickness of the system. It tells how fast the system is tracking the changes in input variables, and most of the embedded system demands first response, which should be almost a real time. Like what is the example here? The response example is like flight control applications. Then coming to the second operation quality attribute is throughput. The throughput deals with the efficiency of a system. It can be defined as the rate of production or operation of a defined process over a stated period of time. And also, the rates can be expressed in terms of products, batches produced, or any other meaningful measurements in the throughput. So, like let us take the example of throughput is in case of card reader, throughput means how many transactions the reader can perform in a minute or in an hour or in a day. That is, throughput is generally measured in terms of the benchmark. So, what do you mean to benchmark? A benchmark is a reference point by which something can be measured. Okay, and another operational quality attribute is reliability. So, what is reliability? It is a measure of how much we can rely upon the proper function of the system. So here we are using the mean time between failure and mean time between repair system. These terms are used in determining the system reliability. So the mean time between failure gives the frequency of failures in hours, weeks, and months, whereas in terms of the mean time to repair specifies how long the system is allowed to be out of the order following a failure. So for embedded system with critical application need, it should be of the order of the minutes. And another category of the operational quality attribute is maintainability. It is very, very important parameter. So it deals with support and maintenance to the end user or client. In case of technical issues and produce failure or on the basis of a routine system checkup. The reliability and maintainability are complementary to each other here. So a more reliable system means a system with less corrective maintainability requirements and vice versa. So the maintainability again can be classified into two types. The first one is scheduled or periodic maintenance, and the second one is maintenance to unexpected failure. Next, another operational quality attribute is security. So what do you mean by security here? The confidentiality, integrity, and availability are three major measures of information of security. So what do you mean by confidentiality? The confidentiality deals with protection of data and application from unauthorized disclosure. And here we have the integrity. The integrity deals with the protection of data and application from unauthorized modification. Here we have the availability also. So the availability deals with protection of data and application from unauthorized users. Okay, and the final quality attributes and of operational quality attribute is safety. So what do you mean by safety? What it deals? The safety deals with possible damages that can happen to the operator, public, and the environment due to the breakdown of an embedded system. What do you mean by breakdown? The breakdown of an embedded system may occur due to a hardware failure or a software failure. So here we have safety analysis is a must in product engineering to evaluate the anticipated damages and determine the best course of action to bring the consequences of damages to acceptable level. These are the operational quality attributes. Then we'll go for the non-operational quality attributes. So the quality attributes that needs to be addressed for the product not to on the basis of operational aspects are grouped under this category. So the non-operational quality attributes are testability and debuggability, availability, portability, and time to prototype and market. Finally, it can be classified as per unit and total cost. So let's see the first one is testability and debuggability of the non-operational quality attributes. So what do you mean by testability? The testability deals with how easily one can test the design, application, and by which means it can be done. And for an embedded system, the testability is applicable to both the embedded hardware and embedded software. So these embedded hardware testing ensures that the peripherals and the total hardware functions in the desired manner, whereas the software testing ensures that the software is functioning in that expected way. So whereas here we have the debuggability. So the debuggability can be classified into two types. One is the hard level debuggability and second one is the software level debuggability. So coming to the hardware debuggability, it is used for finding the issues created by the hardware problem. Coming to the software level, it is employed for finding the errors created by the flaws in the software. Okay. Next, coming to the second non-operational quality attributes is availability. So what do you mean by availability? It is a term which is closely related to the biology, like it is referred as the non-heritable variation. So for an embedded system, availability refers to the easy with which the embedded product can be modified to take advantage of new software or hardware technologies. And coming to the portability non-operational quality attributes, here it is the measure of system independence and an embedded product is said to be portable if the product is capable of functioning in various environments, targets, processors, and embedded operating system. And here we are using the porting. Okay, porting represents the migration of the embedded system software written for one target processor to a different target processor. And coming to the time to prototype and market non-operational quality attribute. So here it is the time elapsed between the conceptualization of a product and the time at which the product is ready for selling. So the commercial embedded product market is highly competitive and time to market the product is critical factor in the success of commercial embedded product. So there are maybe multiple players in embedded industry who develop products of the same category like mobile phones. And the final non-operational quality attributes is for unit cost and revenue. So what do you mean by cost? Cost is a factor which is closely monitored by both end user and product manufacturer. So cost is highly sensitive parameter for commercial products. So any failure to position the cost of a commercial product at a nominal rate may lead to the failure of the product in the market. So we need to study the proper market and cost benefit analysis should be carried out before taking a decision on the for unit cost of the embedded product. So the ultimate aim of the product is to generate marginal profits. So the budget and total cost should be properly balanced to provide a marginal profit. Okay, these are the non-operational quality attributes. Next, in the coming section, we'll go for the purpose of the embedded system. Then we'll discuss about the hardware components of the embedded system. Thank you.